Finding gradients. We want to find the gradient of the line segment that joins these 2 points. The way to do this is to form a right-angled triangle where the 2 shorter sides are horizontal and vertical. If we look at the x-coordinates, here the coordinate is x1 and here it's x2. Therefore the distance along here would be x2 take away x1. It's just like if we have a point here and a point here, and let's say this one is at 3, 5 and this one is at 9, 5, then the distance between them, note they're on the same horizontal line, is 6, which is just 9 take away 3. So if we subtract the x-coordinates, we get this distance. In the same way, the vertical distance here is y2 minus y1. Now, the gradient is defined as the difference in the y-coordinates over the difference in the x-coordinates. Or another way of looking at that is rise, so how far up or down you go, divided by run, which is how far across you go. So the gradient is going to be y2 minus y1 over x2 minus x1. And note the order is important here. If this point is x2, y2, this must be the y-coordinate of this point, and the x2 must be the x-coordinate of that point. So the order is important here. We want to find the gradient of the line joining the pairs of points. So we have -1, 3 and 5, 4. Well, let's say we call this one x1, y1 and this one x2, y2. Then we know the gradient is y2 minus y1 over x2 minus x1. So in this case y2 is 4, y1 is 3, x2 is 5, and x1 is -1. So that ends up being 1 over 6. So our gradient is 1/6. Here let's this one be x1 and y1, this one be x2 and y2. Then we know the gradient is y2 minus y1 over x2 minus x1. So y2 is 8, y1 is 3, x2 is -2, and x1 is -12. So that gives us 5 over -2 plus 12, which is 10, giving us a gradient of 1/2. Now we don't have to use the formula, there are other ways of doing this. For example, if we make use of a sketch, I can just draw a point here and say it's -12, 3, and compared to that, -2, 8 would be to the right and up a bit, so -2, 8, and then we're after the gradient of this line, so we form a right-angled triangle. And then we just say going from -12 to 2 to -2 must mean I'm going across by 10. From 3 to 8 must mean I'm going up 5. And then the gradient is the rise divided by the run, which gives us a half. So the formula sometimes is very useful, but you can also do this just by sketching and figuring out the rise and the run. The line joining 3, -5 and 6a has gradient 4. Work out the value of a. So if we let this point be x1, y1, and this one be x2, y2, then we know that the gradient is y2 take away y1 over x2 minus x1. So y2 in this case was a, y1 is -5, x2 is 6, and x1 is 3. And we know that that's going to be equal to the gradient, which is 4. Minus minus gives us a plus, so that's a plus 5 over 3 is equal to 4. And now we just need to solve this linear equation. Multiplying both sides by 3 gives me that a plus 5 is equal to 12. And then subtracting 5 from both sides gives me that a is equal to 7. We want to find the gradient of each line shown. Now, this is a grid point, so where it goes through the actual grid, or where two lines cross, and this appears to be another grid point just here. So we'll make use of these 2 points. I could call this one x1, y1, and this one x2, y2, and use the formula. Or we could just form a right-angled triangle here and say that we can see that the run, the distance across to the right, is 3, and the rise is 1, 2, 3, 4, 5, 6, and then the gradient is the rise divided by the run, which is 6 divided by 3, giving us 2. Now for this one, let's do the same sort of thing. We'll find 2 grid points. Now I think that seems to be a grid point just there, and this one seems to be a grid point. Now always form your right-angled triangle by going across to the right first, so that the run is positive. And I can see that's gone across by 8, but we've gone downwards by 2. So that's negative because we went downwards. Then the gradient is the rise over the run, which is -2 over 8, giving us -1/4. Now when a line slopes downwards like this, going from left to right, the gradient is always negative, so that's a little check that you've got it right, that we can see this is sloping downwards and we would expect a negative gradient.